This is 3.6 Combining Functions, Day 2. We are looking at this interesting notation where we have f and g as functions with this little circle in between. And what that really is saying is f of g of x. F of g of x. And we can rewrite that as in the notation where we have f in parentheses, then g parentheses of x. So f of g of x. So basically, whatever you have for an expression for g of x, that will be plugged in for f of x. And so if we look at these examples where we need to find f of g, g of f, f of f, and g of f, or I'm sorry, g of g, and their domains, and we have the two functions, f of x equals x cubed plus 2, and g of x equals the cube root of x. So for f of g, the function of g of x is we're going to take f of the cube root of x. And we're going to take the cube root of x and plug it in for x. So we're going to take the cube root of x cubed plus 2. And the cube root of x cubed is just x. And we get plus 2. So f of g of x is equal to x plus 2. Now the domain, you have to look at the combination of x cubed plus 2 and the cube root of x. Well, there are no restrictions on either one of these. There's no radical and no fraction for f of x, and the radical for g of x is cube root, which is no restriction. It's not a problem. It's when it's square root, fourth root, sixth root, anything even for the radical that is going to cause a restriction. So the domain is all real numbers going from negative infinity to positive infinity. G of f is taking the function of g, and we are going to plug in x cubed plus 2. And what we get is the cube root of x cubed plus 2. And we look to see if we can simplify that, and we cannot. So we're done. So g of f of x is equal to the cube root of x cubed plus 2. The domain, because there are no restrictions in the outcome and no restrictions from the beginning, we have all real numbers. For f of f, we are taking the function of f, and we are going to plug in x cubed plus 2 into itself. We're going to take that and plug it into x. So we get x cubed plus 2 cubed. So that's your x cubed, and then plus 2. And what needs to happen is we need to simplify this. We need to actually multiply this out. So we need to take x cubed plus 2 times x cubed plus 2 times x cubed plus 2. We will start off with just 2 of them and do FOIL. We will get x to the 6th plus 2x to the 3rd plus 2x to the third plus 4. That will give us x to the sixth plus 4x to the third plus 4. And then multiply that times x cubed plus 2. And we do the essentially FOIL, but it's now called distribution of terms. We do x to the sixth times x to the third, which is x to the ninth. X to the sixth times 2 is going to be 2x to the sixth. We have 4x squared, 4x cubed times x cubed, which is going to be 4x to the sixth. 4x cubed times 2 is going to be 8x cubed. And we have 4 times x cubed and 4 times 2, which is 8. Now we look to combine like terms. We have x to the ninth plus 2x to the sixth and 4x to the sixth, which is 6x to the sixth. We have 8x to the third and 4x to the third, which is 12x to the third, and then the 8 plus 8. So we have f of x is equal to x to the ninth plus 6x to the sixth plus 12x to the third plus 8. Oh, I also have the plus 2 out here. So we have to add the 2. I almost forgot about that. So plus 10. So x to the ninth plus 6x to the sixth plus 12x to the third plus 8 plus 10. Okay, when we look at that, initially we don't have any domain restrictions. In our final outcome, we have no domain restrictions, and therefore our domain is all real numbers, going from negative infinity to positive infinity. And then we look at g of g. Okay, well, g is the cube root of x. So we're taking g of the cube root of x. So we're taking the cube root of x inside the cube root of x. So yeah, the cube root of x is replacing the x in the initial function. So we simplify this, and we get, when we have the cube root and the cube root, that's like exponent to exponent. We multiply those, and we get to the ninth root. So the ninth root of x. And no restrictions from the beginning, no restrictions here. So our domain happens to be all real numbers again. Okay? So that's what we're doing with f composition, f of g, g of f of f, and g of g. Now let's look at this example where we have three functions, f of g of h, also written like that. We have f of x is 1 over x, g of x is x cubed, and h of x is x squared plus 2. So we start, we have the fact that this x squared plus 2 is going to go in for x in the g of x. So we have x squared plus 2 cubed. And then that is going to go in to f of x. So what I have here for g of x is going to replace the x. So f of g of h of x is going to be 1 over this x squared plus 2 cubed. So what I'm going to do is take the x squared plus 2. So x squared plus 2 cubed. sorry, times x squared plus 2 times x squared plus 2. And we just did that down here, where we took x cubed plus 2 to the third. And when we did that, we got x to the ninth plus 6x to the sixth plus 12x cubed plus 8. And so this is x to the ninth plus 6x to the sixth plus 12x to the third plus 8. And so we have 1 over all of that. Which is then going to give us our final simplification of f of g of h. Okay, looking at these, we want to express the function in the form of f of g. So we're given a function written in what we would consider like its final state. And we need to somehow separate this into two functions. So if we think about what functions we have x to the exponent, we have the radical of x, we have absolute value of x, and we have 1 over x, or any type of expression. So, and we have linear. So we have like y equals mx plus b. Okay. So we look to see what type of function we have within another function. And when we look at this, we have the square root of x plus 1. So we could have taken what we have to look at this as is we took the square root of x and we plug it in to x plus 1. We have x plus 1 and we have the square root of x. And the square root of x was replacing x into the x plus 1. So we could say that um, f of x is the x plus 1, since the g is what goes into the f. Because if we think about how this is written, it's f of g of x. And so the function of g is what is going in to f. So this is f and this is g. So g is going into f. So if f of x is the x plus 1, then g of x is the square root of x. Okay? And down below, we have a fraction. So the initial function would be we have x cubed both in the numerator and the denominator. So I think what I would say is that x cubed is being plugged in, and we could say that f of x is x over x minus 5, and g of x is the x cubed. So x cubed is replacing x from the function of f. Okay, so we would take x to the third and plug in for x here to get x to the third, and then for the denominator, plug in x to the third to get x cubed minus 5. Okay, now if we had, multiple, if we wanted f of g of h, we could do a little bit more with that. But since we were limited to two functions, we had to think, okay, what was common in here with the top and the bottom with this fraction, because the fraction is kind of like a function in itself. And how did we modify that fraction? Okay, so that is the notes for day 2 of 3.6.